Hello, and welcome to another RPD video. In this video, we'll be talking about retentive clasps. The retentive clasps do the important job of keeping the RPD in place while it's in function. They do that by engaging retentive undercuts on the tooth surface. Undercuts are areas underneath the height of contour of a tooth. The height of contour is the widest circumference on the tooth surface. The way I like to explain it is, imagine having the tooth underneath a light source. When a light is shined onto the tooth, it'll cast a shadow under the widest area of the tooth. The parts of the tooth that are in shadow are considered an undercut. Retentive clasps come in two main categories: gingivally approaching clasps and occlusally approaching clasps. Occlusally approaching clasps approach the undercut from an occlusal direction, which makes them relatively simple. However, their presence on the occlusal side of the tooth makes them not very aesthetic. Gingivally approaching clasps approach the undercut from a gingival direction. Because of that, they're more aesthetic. However, they need 3 mm of buccal vestibular depth and can cause food entrapment if associated with a buccal soft tissue undercut. There are many types of occlusally and gingivally approaching clasps. We'll talk about some of the most common ones and some special use clasps. Let's start with the commonly used clasps. Generally, the preference is to use simple clasps whenever possible and avoid the more complex clasps. In this next section, we'll go over the details of each clasps, starting with the most simple and most likely to be used clasps, and ending with the more complex and last resort clasps. To aid in your understanding, we'll be depicting the partial denture and the abutment teeth as such. We'll also be depicting the undercuts as those gray areas under the height of contour, like this. Now let's start with the simplest and most commonly used clasp, the cast circumferential CC or Aker's clasp. It is an occlusally approaching clasp that engages molars, premolars, and incisors. It engages a 0.01 inch undercut on the buccal or lingual sides of the tooth, and the obvious disadvantage is its aesthetics. So if a patient has high aesthetic concerns and doesn't like the look of a CC clasp, it's recommended to shift over to an I-bar clasp. I-bar clasps are one of the simplest gingivally approaching clasps. They also engage 0.01 undercuts, however, they're not recommended to be used on molars or the lingual surfaces of teeth. They also are not recommended to be used in areas with less than 3 mm of gingival vestibular depth or areas with soft tissue undercut. Let's shift gears. In areas where the tooth has been lost for a long time, it's not uncommon for teeth to tip into the edentulous space. When they do that, the height of contour and the retentive undercut move closer to the edentulous space, which makes them inaccessible to the CC and I-bar clasp. In this case, we'll have to shift over to more complex clasps like the modified T and the ring clasp. Modified T-clasp is a gingivally approaching clasp that, like the I-bar, cannot engage molars or the lingual surfaces of teeth. However, what it can do is engage undercuts that are close to the edentulous area, much like the ring clasp. The ring clasp is an occlusally approaching clasp that specializes in engaging undercuts on molars that are tipped forward like this, in which the undercut is closer to the edentulous space. Because the ring clasp arm goes around the distal surface of the tooth, it can be only used if that molar is the most distal tooth in the arch, because any other tooth adjacent to it would interfere with that clasp arm. Let's consider that our patient is a little bit more complex. In the anterior region, we notice that the patient has less than 3 mm of vestibular depth and a buccal soft tissue undercut. And on the distal side, we notice an adjacent tooth, which interferes with the ring clasp arm. Because of those reasons, the modified T-clasp and the ring clasp are no longer compatible, and we'll have to move on to the most complex and least desirable clasps, the hairpin clasps. Hairpin clasps are occlusally approaching clasps that engage 0.01 inch undercuts on the buccal or lingual sides of incisors, molars, or premolars. They specialize in engaging undercuts that are closer to the edentulous space. However, the fact that they are not desirable stems from the multiple disadvantages, including aesthetics and its complex design that might lead to food entrapment and fracture. A commonly asked question is, why should we even attempt to use those hairpin clasps? Why can't we just use an I-bar and a CC clasp that go directly to the undercut, even if the teeth are tipped? The reason is using a short I-bar clasp would lead to foot entrapment, and a short circumferential clasp would cause it to not be flexible enough to go in and out of an undercut. Now that we're done with the most commonly used clasps, it's time to move on to the special use clasps, like the Wrought wire and the Embrasure clasp. Wrought wire clasps are made out of a different material than all the other clasps. They're pre-made round wrought wires that are soldered onto the framework after the framework is cast. Because of this, these clasps are exceedingly flexible. So in order to provide enough retention, they need to engage a deeper undercut than any of the other clasps. So this is the only clasp that engages a 0.02 inch undercut on a tooth. Wrought wire clasps are considered occlusally approaching clasps, which give them the same disadvantage as the CC and the ring clasp, which is lack of aesthetics. However, they have an additional disadvantage of being complex and losing retention faster than most other cast clasps. So why do we ever use it? The only indications are for periodontally weakened teeth. That is because their flexibility allows for less forces on those teeth. The other indication is on an anterior abutment of a modification space of a Class 2 Mod 1. The reasons behind this are explained in a lecture linked in the description below. The other special use clasp is an Embrasure clasp. Embrasure clasps, also commonly known as double cast circumferential clasps, do look like two circumferential clasps that are back to back. They are used in some specific aesthetic situations, which are explained in a lecture that we'll link below, and they're commonly associated with embrasure rest seats, which we have explained in another lecture that we will also link below. The disadvantage of those embrasure rest seats that are associated with those clasps is that they require a ton of occlusal reduction, which again is not needed unless you really need to use those clasps, so they're reserved for those special situations that are linked down in the description. Now that we're done with the majority of the clasps, it's important to know that because clasps are one part of the clasp assembly, there have been names given to clasp assemblies in which the clasps play a role. For example, the RPI is a combination of a mesial rest, a proximal plate, and an I-bar clasp. The RPA clasp is a combination of a mesial rest, a proximal plate, and an Aker's or a CC clasp. And the combination clasp assembly is given to the combination of a wrought wire clasp to a cast frame. And that brings us to the end of the lecture. We hope it was helpful, and we'll see you guys in the next RPD video.